hydrogen peroxide, H2O2, hydrogen peroxide. It is a very important laboratory reagent. We will learn that, of course, in the properties. Preparation. Any peroxide plus dilute acid, you get hydrogen peroxide. Any peroxide, you should start with a peroxide. Look here. Na2O2 plus H2SO4 dilute. Will you get H2O2? Depends on whether this is a peroxide or not. Is Na2O2 a peroxide? We discussed in the oxidation states part, the last lecture, Na2O2 plus 1, plus 2, minus 2, O2 2 minus. So, when O2 2 minus, if O2 is 2 minus, we know it is called a peroxide, or O minus, or oxygen single bond. There is a lot of chemistry in this oxygen single bond, you will be surprised. Too much of chemistry is there in oxygen single bond compounds containing that peroxy bond. Now, Na2O2, so therefore this is a peroxide, sodium peroxide plus H2SO4, you will get Na2SO4 plus H2O2. This is called the Merck's process, names not necessary. H2O2. PbO2 plus H2SO4. Will you get H2O2? Will you get H2O2? You will if this is a peroxide. If this is a peroxide, you will get H2O2. But is PbO2 a peroxide? Let us see. Give minus 2 to oxygen, minus 4. Lead is plus 4. Therefore, it is not a peroxide. Oxygen is minus 2 here because lead doesn't mind giving minus 2 to oxygen. Lead doesn't mind allowing oxygen to be minus 2. So, even if it is minus 2, lead can still take plus 2. Therefore, not a peroxide, not a true peroxide. Why do you say it is not a true peroxide? Earlier it was called lead peroxide. Though it is not a peroxide, it was called peroxide. Therefore, you don't get H2O2. Next, BaO2 plus H2SO4 dilute, you definitely, this is barium peroxide, plus 2, minus 2. Barium is fixed, you know, barium has a fixed oxidation state, plus 2 only. Barium can be plus 2 only, therefore this is minus 2. You will get H2O2. But along with H2O2, you get BaSO4. And this BaSO4 precipitate forms a layer on this BaO2. Therefore, this method is not used. This method is not used because BaSO4 forms a layer. So, that is the role of BaSO4. Wherever you have BaSO4, that doesn't allow the reaction to go further. It almost acts like a negative catalyst. So, you find BaSO4 at many places where the reaction does not go to completion. It stops midway through. So, BaSO4 forms a layer. Therefore, this is not used. Though you get H2O2, this is not used. So, then how is H2O2 prepared from barium peroxide? BaO2 plus H2O plus CO2, you get BaCO3 plus H2O2, hydrogen peroxide, H2O2. So, how is hydrogen peroxide prepared in the laboratory? By adding dilute acid to this one. Next, it can also be prepared by the electrolysis of 50% H2SO4. electrolysis depends on the concentration of the electrolyte. Suppose if you take concentrated H2SO4, what do you mean by concentrated H2SO4? It doesn't contain much of water. No water, no ions, no electrolysis. Concentrated H2SO4 means ionization will not be there. And dilute H2SO4 means it is nothing but water. Dilute H2SO4 is nothing but water. The water, some is added. So 50% H2SO4, it will undergo partial ionization. It produces H plus and HSO4 minus ions. H plus and HSO4 minus ions. And H plus ions are liberated at cathode. You get H2 at cathode. And this HSO4 minus goes to anode. And it will become H2S2O8, which is called per-disulfuric acid. Per-disulfuric acid, also called Marshall's acid. Names not necessary. And when you add water to this H2O, you get H2SO5 and H2SO4. This time it is called per-monosulfuric acid. Per-monosulfuric acid, also called Carros acid. Carros acid. And when you add more water to this H2O, you will get H2O2 plus H2SO4 again. Okay. So, electrolysis of 50% H2SO4, H plus HSO4 minus will produce H2S2O8 and H2SO5.